All right, in this video, we're going to graph inequalities. As a refresher, to remind ourselves what is a solution to inequality, again, remember that it's any value that creates a true statement. If you get a true statement, then we know that is a solution. Now, inequalities differ from equations in that generally equations have one solution, whereas inequalities can have infinitely many. So that's a generalization. It's not always going to be true, but it's a good guideline. A couple examples here, right? So we want to know, is -4 a solution to the given equality? So when I'm taking a look at this first one here, is -4 less than 2? Is that true? Well, that's true. So it's true. That's true. So yes is our answer. All right, next one. Now this statement is a between statement. So is 3 less than x and is x less than 5? Right? So is 3 less than x and is x less than 5? So is 3 less than -4 and is it less than 5? The answer is no, that's false. All right, so it's not a solution. Right. Next one is an or statement or beyond. In this case, it just needs to be true for one of these, and then it's true for the whole. It's a solution for both. So if it's true for one of these, it's a solution to the inequality. So let's check this first one. Is -4 less than or equal to -2? Well, that's true. Okay, so we could say, but I'm just going to verify, right? And this one's -4 greater than 4. Well, that one's false. Well, because this is an or statement, right? So because this is an or statement, all we need is one of these to be true, then it is a solution. So we got a true statement here. We can then say, yes, this is a solution. All right, so now that reminds ourselves of there are two types of compound inequalities. All right, there's and statements and or statements. Now, sometimes you might hear them. This is called a between statement, and this is known as a beyond statement. Generally, you're going to not see the word and. You're going to see what's this string of a compound inequality, right? That should be a between statement, and you'll notice the inequalities are both the same. Okay, these two are what we call our critical points. Right? For an or statement or beyond statement, right? You would always see the word or. And you'll see two inequalities here. Generally, the inequalities do not match. Usually, they don't match. But that's just a generalization. Now, again, they're going to give you some critical points. Now, how do we graph inequalities? Now, 3 steps. First one, locate critical points. Mark them open or closed. So they're open if you have less than or greater than, they're closed. Less than equal to or greater than equal to. Right. Then you choose a test point. That's not a critical point. Right. Make sure that it's not a critical point. Right. And then check to see if it's a solution. If it is a solution, you want to shade the sections. So basically, the critical points sometimes are known as boundary points. They're the borders, and so they will give us insight as to how to divide that number line up. So let's take a look at this first example here. So for that first step, I recognize that this is a critical point. It is going to be an open circle because of this, so open. So these are all things that I'm thinking about, right? I don't really need to show that. I'm going to label that point though, right? It's open, so I'm not going to fill that circle. And now I need to figure out, oh, and I should mark it. So it's at 2. So now I want to choose either a point less than 2 or greater than 2 as a test point and check it out. So test point. Now 0 isn't a critical point, so I recommend usually 0 is pretty good. So 0, is that less than 2? That is true, right? So 0 would be somewhere to the left, so that's the side I'm going to shade. Next one, we have a compound statement. So it has 2 critical points, and both of them are going to be open. So 2 critical points, and they're open. So 3 and a 5, and they're both open. I'm going to choose a test point. I'm going to choose So in this case, let's choose 0 again. So is 3 less than, or sorry, is 3 greater than 0, less than 5? That's false. Okay, so I want to go until I can find something true. I'm going to check over here. Number between 3 and 5 would be 4. So is 3 less than 4, and is 4 less than 5? That's true. So I'm going to shade in that part. And if you want to verify, you could pick something over here. Is 3 less than 6? Is 6 less than 5? That's false, because 6 is not less than 5. So done. Okay, so for this last example, we've got 2 critical points still. All right, we've got a -2 and a 4. And we can see in this one, we're going to want to fill the circles because we've got the equal to part in there. So we're going to fill in those circles. Now we've got to check a test point. Now, because this is a beyond statement or an or statement, we just need to be true on one of these. So once I've true on one, we're good. Let's check a point over here. So -3, is that less than or equal to -2? That's going to be true. So I'm going to shade in that direction. I'm going to choose something in between -2 and 4. I'll pick 0. So 0 less than -2. That's false. Let's check the other one. Is 0 greater than 4? That's false as well. So nothing in between there. And then let's pick something greater than 4. Let's pick 5. So is 5 less than -2? That's false. But is 5 greater than 4? That's true. So we got a true there. There we go. And that's how we graph inequalities.